All right, welcome back. I'm Caleb from Timpson, and today we're going to talk about capacitor banks. And I've got a lot of questions over the years and on previous videos about what a capacitor bank is and what exactly it does. So we're not going to get into a whole lot of detail on it because the detail gets really complicated. But essentially, capacitor banks correct power factor. And I drew a kind of a rudimentary drawing of a capacitor bank up there. There's a few different kinds that you're going to see in the field. There is a fixed bank, which is where the capacitors are hardwired to the line and they're on all the time. Then there's a timed bank, which would be on some type of time clock. So the time clock would click on at peak hours and the capacitor bank would kick on. And then there's a bank with a sensor that has Kyle switches on it, like the one I drew. And when that sensor reads the power factor and the power factor is low, the bank automatically kicks in and corrects power factor. Now, power factor correction falls in with like inductive reactance and capacitive reactance. So on distribution lines for distribution linemen, we're almost always going to be inductive. We're going to have inductive reactance on the line, and that's from a lot of transformers, motor loads from factories, pumping stations, big facilities, people's homes. You know, you have a lot of houses of ACs running and refrigerators and this, that, well pumps. All these things make inductive reactance. And to correct that, we have capacitor banks. Now, if we look, inductive reactance is when your current waveform, so you have your AC waveform, one cycle, straw cycle, right? That's one cycle of your AC waveform. Your current waveform should be in phase with it. If your current waveform lags or leads, if it leads, it's capacitive. If it lags, it's inductive. When your current waveform lags your AC waveform, think of it like this. Your current waveform takes a lasso and throws and catches your AC waveform. And then the current waveform starts dragging its feet. So now your AC waveform, your AC voltage, that electromotive force is doing extra work that it's trying to run harder to do the same amount of work. Well, what ends up happening is as your current waveform is dragging its feet, your AC voltage sags. So you start getting a low voltage. Now what the capacitor bank does is it sends a army of badasses down the line. They run down the line and kick that current waveform in the rear end and speed it up. And as it speeds up, it's less work for your AC voltage and the voltage rises back up. Now, that's not exactly what happens, but it's an easier way of explaining it. Your current waveform slows the voltage down and the capacitor bank speeds it back up. We see capacitor banks less and less as time goes on, and that's because historically, if we went back in time, we had two types of loads in the utility industry. In distribution, you had inductive loads and you had resistive loads. Resistive loads would be like your electric range or electric baseboard heater or an electric hot water heater, your toaster, all resistive loads. Inductive loads would be like your well pump, your refrigerator, your washing machine, your AC, at a big factory, any type of motors. Well, as we've gotten further and further in the industry, more and more efficient, a lot of that stuff has become, DC motors that's run through variable frequency drives, and you have rectifiers, you have all these things that flatten out the AC waveform. So that's starting to change a little bit. And we have less need for a lot of capacitor banks, but there still is a need for them. And capacitor bank maintenance is very, very important, but it's also a very dangerous job. And we can get into that on a later video. But if you have any other questions on capacitor banks, if you want me to go into the actual detail, the science behind what happens, I certainly can if you leave some comments down saying you want to hear that. Or if you have any questions on what I just talked about, you can throw it down in the comments and I'll be sure to answer it. Also, if you have any ideas on future videos that you'd like to see, throw it down in the comments. I'll see if I can get that done. Thanks, guys.